P is the root of this equation. At the very end, I'll keep an eye on this. They want me to find the value of P. So P is a root. What do I know about a root? Well, I can either know that if I have a root, I can sub it in, or if I have a root, I can turn it into a factor and do long division. So I'm gonna say that x is equal to P. So the missing number, if I solve the equation, one of the roots is P. So anywhere I have an x, I'm gonna throw in a P. So that's 3 times P cubed plus P plus 3 times P squared plus 7 minus P minus 4P squared times a P minus a 4 equals 0. So that gives me 3P cubed plus a P cubed plus a 3P squared plus a 7P minus a P squared minus a 4P cubed minus a 4 equals 0. So that is 3P cubed. They cross off. I end up with a 3P squared plus a 7P minus 4 equals 0. Quadratic. Here we go. So this is the most common way to finish a question. You solve your quadratic, whether you throw it into minus b formula or you solve it with your factors, and you end up with P equals a half and P equals minus 4. And if I just go back to here, just checking the way they want the answer given, P has to be an integer. There's my only answer. Hence solve the equation. Well, now that I know that P is minus 4, I have a 3x cubed plus a minus 4 plus 3x squared plus a 7 minus 4 minus 4 times minus 4 squared times x minus 4 equals 0. Sorry, I've kind of gone off the page there. Clean that up and it should end up looking like 3x cubed minus an x squared minus 53x minus 4 equals 0. Right, so I have a cubic. How do I solve a cubic? Well, I hope that I have a root. If not, I'll have to go find one. Turn my root into a factor and do long division. So I do have a root. P is a root. I'm just finding out P is minus 4, so x minus equals to minus 4. There's my root. Turn it into a factor. It's x plus 4. Do my long division. 3x cubed minus x squared. 3x minus 4. So just take your time with the long division. Plus 12x squared minus. So that gives me 11x squared. No. So, sorry, it's the plus 12 and it turns to a minus. So minus 13x squared. And then I have minus 53x minus 4. And I go again and multiply by minus 13x minus 13x squared. And that gives me minus 52. No. 52x. And I subtract plus, and that gives me a minus 1x minus a 4. So just take your time with the long division. It should all work out because we know that x plus 4 is a factor. Here's my quadratic. I'll end up with 2 solutions from this, my other 2 roots. Probably a suggestion here that I'm going to end up looking at the minus b formula. So throw it into minus b formula and you'll get again, look, same quadratic, most common way to finish a question. So if you throw it into the minus b formula, you should get the roots. 13 minus root 181 over 6. 13 plus root 181 over 6. And then, you know, write all your solutions down. Well, the other one we said was a minus 4. A few ways to do this. I might try and do it maybe 2 different ways. So we have a root. I actually have 2 there, so we know that x equals minus 2, x equals minus 2, x equals 3. I guess I might as well just take into account that that's the point 0, 0.24. And even at that, I probably know already that d is 24. Now, if you wanted to, you could, you know, it's where it cuts the y-axis, but even if you wanted to, you can sub in x is 0, y is 24, and you end up with d is 24. So I know that already from the start. So at the minute, I know that f of x is equal to something x cubed plus something x squared plus something x plus 24. So I already have something there that should get me my attempt marks. So loads of ways to do this. As I said, you could, you know, sub in, you know, if that's minus 2, 0, you could sub that in, minus 2, 0, sub that in, and 3, 0, sub that in. Or you could realise that you have the roots of the equation, which means turning the roots into factors should get me even just a version, maybe kind of like the parent function nearly of the equation. So we have some, so sorry, I'm getting confused between the two different ways. X plus 2 is a factor, x plus 2 is a factor, and x minus 3. Multiply that out and it should clear up to an x cubed plus an x squared minus 8x minus 12. So this is like, you know, if we were sketching this, it would look like so. We have 2 roots and there, bouncing off that, and then there at the 3. This looks like a plus 1. So, sorry, so it bounces off there, sorry, and then goes up there. So this is kind of like an image of the function that we have here. Well, that's not what I have here, so I know that's not the exact one. So it's a version of this. So, you know, multiplying it by 2 might kind of spread it out a bit or narrow it down a bit. Hopefully you know your transformations of your functions and your translations. Adding a 2 would move it up, subtracting a 2 would move it down, etc. So if we look here, we already know that this is a 24. So what happened to the very last part here, it was multiplied by a minus 2. So to multiply by a minus flips it, and to multiply by a 2, you know, it might be a kind of a more spread out version of this. That's what I'm going to do. So my coefficient here is a minus 2. So I end up with minus 2 x cubed minus 2 x squared plus 16x plus 24. There's my function. Another way of doing that is, as I said, there's a point, sub it in. You'll find out what d is straight away. Here's a point, sub it in. You'll still be missing a, b, and c, but you'll end up with one part of a simultaneous equation. You could get this point, sub it in into this, you will end up with a second line of a simultaneous equation. And if you need a third one, which you will because you'll be missing A, B and C, so we already have D from this part, but we'll need a third equation when we have three things still missing. So the A, B and the C will still be missing. And that means that we have a turning point here at minus 2, 0. You could differentiate this, so f dash of x could become 3ax squared plus 2bx plus c. What do you know? When you have a turning point, the slope is 0. So that's equal to 0 when x is minus 2. So you could use that information, find your third one, and then you'd be solving three simultaneous equations. At the minute, I've done it this way fully out. You could try it this way as well if you want. And I end up with that's minus 2, that's a minus 2 also, that's a 16, and that's 24.